In example 2, we're going to sketch the graph of a symmetric function. A person's happiness can be affected by temperature. Move through the slides to see how to sketch a nonlinear graph that shows the happiness of a person y as a function of temperature x. Interpret the key features. So our key features are here. We're positive between 25 degrees Fahrenheit and 89 degrees Fahrenheit. We're negative for temperatures less than 25 and greater than 89. We're increasing for temperatures less than 57. We're decreasing for temperatures greater than 57. So our relative maximum is at 57 degrees Fahrenheit, where a person's happiness is about 85. Right? This is the peak of happiness based on temperature. The end behavior: as temperature increases or decreases, a person's happiness decreases. Right? So the colder it is, the sadder we are, and the hotter it is, the sadder we are. Symmetry: a person's happiness for temperature less than 57 degrees Fahrenheit is the same as their happiness for temperatures greater than 57 degrees Fahrenheit. One method for sketching a graph given key features is to first graph any given points, then analyze the key features in small intervals from left to right to make sketching the graph of the function easier. Since we know the relative maximum at about 57 degrees Fahrenheit, when a person's happiness is about 85, we are going to put a point at 57, 85, right there. A relative maximum occurs at 57, so x equals 57, and the happiness is 85, so y equals 85. This was represented by the point 57, 85, which we can graph on the coordinate plane, right there. Next, we know that it's negative for temperatures less than 25 degrees and increasing for temperatures less than 57 degrees. So for temperatures less than 25 degrees, or when x is less than 25, the graph is negative. For these temperatures, the graph is also increasing. So we know it's going up towards our dot. We know that it's positive between 25 and 89, and it's increasing for temperatures less than 57. So for temperatures between 25 and 57, the graph is positive and increasing. So we're starting here at the x-axis and we're going up towards our dot. It's positive between 25 and 89, which we stated earlier, between 25 and 89. It's decreasing for temperatures greater than 57, so we know we have to come back down to 89. And the symmetry of a person's happiness for temperature less than 57 is the same as their happiness for temperatures greater than 57, so we know that it has to mirror that. The graph is positive and decreasing for temperatures between 57 and 89. This interval of the graph is also symmetric to the graph from 25 to 57. This means that the right half of the graph is a mirror image of the left half. And lastly, it's negative for temperatures greater than 89, decreasing for temperatures greater than 57. And this person's happiness for temperatures less than 57 is the same as their happiness for temperatures greater than 57. So for temperatures greater than 89, or when x is greater than 89, the graph is negative, decreasing, and symmetric to the interval of the graph that is less than 25. So we know that we're going to have a little line right here going down from 89 that is mirrored of the one going up to 25. The end behavior: as temperature increases or decreases, a person's happiness decreases. So we know we've got some arrows going down. As temperature increases this way or decreases this way, a person's happiness decreases. This means that the happiness will get increasingly negative to move right or left on the graph. A person is happiness when it's about 57 degrees Fahrenheit. As the temperature gets increasingly cold or hot, a person becomes less happy. When the temperature is below about 25 degrees or above about 89 degrees, a person is very unhappy. Now, me personally, I like it a little bit more warmer than 57. So we would have to take this little curve guy here and move it up about here to 70. That's when I'm about the happiest. Where is your happy point.